In this video, you'll learn the foundational model that makes Power BI faster, clearer, and easier to use, the STAR schema. We'll follow Microsoft's official guidance step by step, so you can design semantic models that are optimized for performance and usability. The semantic models rely on Power Query to connect to or import data. That means you use Power Query to shape and prepare your source data. When volumes get large or you need advanced concepts like slowly changing dimensions, consider building a data warehouse with ETL processes and then connect your model to it. This video isn't a complete design course, but it gives you a proven framework to get it right. For a deep dive on dimensional modeling, see the Data Warehouse Toolkit by Ralph Kimball and others. Here, we'll stay practical and focused on what you need for Power BI. A STAR schema is a mature modeling approach widely used by relational data warehouses. You classify your model tables as either dimensions or facts. Dimension tables describe business entities, the things you model, such as products, people, places, and concepts, including time. A date dimension is almost always present. A dimension contains a key column that uniquely identifies each row, and attribute columns used for filtering and grouping. Your fact tables store observations or events, sales orders, stock balances, exchange rates, temperatures, and more. A fact table includes dimension key columns that relate to dimension tables and numeric measure columns. The dimension keys define the dimensionality of a fact table. The key values define its granularity. For example, a sales goals fact with date and product key has two dimensions. If the date values are the first day of each month, granularity is monthly at the product level. Dimensions usually have relatively fewer rows. Fact tables can be very large and grow over time. Normalization reduces repeated data. A normalized sales table stores only keys like product key. Product attributes live in a separate dimension. If a sales table stores product attributes directly alongside the keys, it is denormalized. Many exports arrive denormalized. Use Power Query to reshape them into normalized fact and dimension tables. Target an optimized semantic model that represents normalized facts and dimensions, with one notable exception we'll cover later. Sometimes you denormalize a snowflake dimension into a single model table for usability. Every report visual generates a query to your model. Queries filter, group, and summarize. A well-designed model exposes tables that are ideal for filtering and grouping, and tables that are ideal for summarizing. That fits STAR schema principles. Dimension tables enable filtering and grouping. Fact tables enable summarization. In Power BI, table type isn't a property you set. It's implied by relationships. One-to-many or many-to-one cardinality determines roles. The one side is always a dimension. The many side is always a fact. Keep your design clean. Tables should be either dimensions or facts, with correct relationships, and facts loaded at a consistent level. And remember, optimal design is part science, part art. Sometimes you'll make thoughtful exceptions. In STAR schema design, a measure is a column in a fact table that is summarized. In Power BI, measures come in two forms. Explicit measures are created with DAX formulas that evaluate at query time. Results aren't stored. Implicit measures are columns that visuals can summarize automatically. Even for simple sums, there are strong reasons to create explicit measures. If authors query via MDX, for example, analyze in Excel, you must provide explicit measures. MDX can't aggregate raw columns. If authors build paginated reports using the MDX query designer and need server-side aggregations evaluated by Power BI, explicit measures are required. To control how a column is summarized, a unit price should not be summed. Expose only appropriate aggregations like MIN, max, or average as explicit measures and hide the raw column. In the data pane, explicit measures show a calculator icon. Implicit aggregations show the sigma. A surrogate key is a unique identifier you add to support STAR schema modeling. If your dimension doesn't have a single unique column, add one. For example, create an index column in Power Query. Then merge that key into the fact query so you can build a one-to-many relationship in the model. A snowflake dimension is a set of normalized tables for a single entity. For example, product category to product subcategory to product. You can mirror that structure in Power BI or combine them into a single denormalized dimension for usability. Trade-offs. Mirroring the snowflake loads more tables, adds relationship columns, increases model size, and lengthens filter paths, often less efficient and less intuitive. You also cannot create a hierarchy spanning multiple tables. Combining into one dimension often improves usability and enables a single hierarchy across levels. It may increase storage if the dimension is large, but is frequently worth it. A slowly changing dimension manages member changes over time. Type 1 overwrites with the latest values, common for supplemental attributes like email or phone. A full refresh of a dimension in Power BI achieves the Type 1 result. Type 2 versions each member. The dimension uses a surrogate key to uniquely identify a version, plus date range columns such as start date and end date, and often a flag like isCurrent. If the source doesn't track versions, a warehouse load process must detect changes, expire the current row by setting end date, and insert a new version with a new start date. Facts must then look up the correct dimension key based on the facts date. Power BI itself doesn't implement SCD Type 2 versioning logic in Power Query. Instead, load from a pre-built SCD Type 2 table. Your semantic model should allow querying by the member regardless of change, and also by a specific version. For example, salesperson versus salesperson version. Make version labels unambiguous, such as David Campbell, December 15th, 2008 to June 26th, 2019, or David Campbell, June 27th, 2019 to current. Educate report authors on filtering correctly and consider providing a hierarchy that lets visuals drill down to the version level. A role-playing dimension lets the same dimension filter facts in different roles. A date dimension might filter sales by order date, ship date, or delivery date. While multiple relationships are possible, only one relationship between two tables can be active at a time. That makes the active path the default, often order date. To use an inactive path, you must write DAX using useRelationship, typically creating separate measures. This can bloat the data pane and takes time to author. There are two important limitations. If authors rely on implicit aggregations, they can't use inactive relationships without creating report-level measures in desktop. With only one active path, you can't simultaneously filter a visual by two date roles. A common solution is to create a separate date table per role. For example, date, ship date, delivery date, each with its own active relationship to the fact. Rename columns to be self-descriptive, such as ship year, and add table descriptions that clarify filter behavior. This avoids multiple alternative measures and enables simultaneous filtering by different date roles at the minor cost of duplicating a small dimension. A junk dimension consolidates many small, low cardinality attributes, like order status or demographic bands, into a single dimension with a surrogate key. It reduces model tables and can shrink storage. Build it as the Cartesian product of attribute members, add a surrogate key, load it as a dimension, and merge its key into the fact query to support a one-to-many relationship. A degenerate dimension is a fact attribute needed for filtering that doesn't justify its own table. For example, order number. Keep it in the fact table for filtering or grouping. If your fact includes both order numbers and line numbers needed for filtering, then creating a one-to-one degenerate dimension table can be a good design. A factless fact table contains only dimension keys, no numeric measures. It can represent events, like a customer logging into your website, where the count of rows is the metric. More importantly, a factless fact is the recommended bridge table for many-to-many relationships between dimensions, for example, assigning sellers to one or more regions. The bridge stores seller key and region key, allowing correct filtering across both dimensions. Star schema principles align perfectly with how Power BI queries work. Dimensions filter and group, facts summarize, relationships define roles. Use explicit measures for control and compatibility, surrogate keys when needed, prefer single table dimensions for usability, manage history with SCD Type 1 or Type 2 in a warehouse, create separate role-playing dimensions for different date filters, and apply junk and degenerate dimensions appropriately. Use factless facts as event tables or bridges for many-to-many.